Okay, on this first problem where it says Naomi's 68 inches tall and you've got to predict the percentile, well, it gives you a hint that her height, there are 20 students that are her height or shorter. Therefore, she's also number 20. So 20 out of 30 would be 0.66 repeating. Therefore, it's rounded up to 67%. Okay, for this next section, we're going to use this problem for the next four problems. We're talking about bags of potatoes, average is 20 pounds, standard deviation of 2. I quickly sketched it right here because what percent of the bags weigh less than 20? Well, less than the average would be 50%. All right. Then I created my graph here for every single problem. So between 18 and 22 pounds, that's going to be 68 pounds per the empirical rule. All right. Same thing for number 4. Number 4, what total percent of bags weigh between 16 pounds and 24 pounds? We're going out to 2 standard deviations, so that takes it out to 95%. And then finally, number 5, what percent of the bags weigh either less than 16, which is here to the left, or more than 24. So if we're talking about 2 standard deviations, remember this is 2.35 and this is 0.15, and it's identical on the other side. These add up to 2.5, therefore this is also 2.5, and when you add that together, you get 5%. On question number 6, if the heights of the middle 68% of the 4th grade students in Texas are between 125 centimeters and 175 centimeters, what is your estimate of the standard deviation of the height of 4th graders, assuming that the distribution is normal with a mean of 150? Well, on that problem, you sketch it. Here's 125 and 175. We know that they are 68%. That indicates the first standard deviation. I know the distance in the middle is going to be 150, but that's not what it's looking for. It's looking for the standard deviation, the distance from here to here. So that distance is going to be 25 centimeters. Notice I use the units of measurement on this. Okay, so on this one, the lifespan of all vacuum cleaners is normally distributed. You have an average of 5 years and a standard deviation of 1. We want to know what the percentage is, so we're looking for the p-value for less than 3 years. So I go over here and I shade it after I've numbered the line. So I find my z-score of 3 minus 5 divided by 1 gives me negative 2 over 1. So that's a z-score of negative 2. Okay, that's supposed to be a negative 2. Now, I'm going to use my table A. So when I use my table A, I'm going to bring this in, and I'm going to look for negative 2.0, which is right here, okay? Negative 2.00. So 0.0228. So I'm going to move that. I'm going to move that over to the side. Okay. Let's try to get rid of that. So then I have a p-value. I have a p-value of 0.0228, which is 2.28%, because we are looking for percent. All right. Now, on number 8, Betsy scored 350, and we want to know what her z-score is. So I just plug that in. 350 minus 500 divided by 100 gives me a standard deviation of negative 1.5. Down here, I want to know how many points did she score. Well, I'm looking for x. So I plug in my z-score, my average, my standard deviation. I then multiply both sides by 100. All right. And then after that, I rewrite it as 175 equals x minus 500. Well, if you add 500 to both sides, you're going to end up getting 675 equals x. And that's the score. That was her score, 675. Okay, on these next 3 problems, we just want to find the area. So I've given you the z is less than 0.41. So z is less than 0.41 is going to be about right here. So we want to shade to the left. And the way we write this is the probability that z is less than 0.41. Now, when you go look at your table A, notice that percentage is going to be more than 50% because it's on the right-hand side. You should get 0.6591 if you look up 0.41 on your table A. Z is greater than 0.41, so basically we want to the right of that. And remember, these two are together, so if I take this area and I subtract from 1, I will get an area of 0.3409. On number 12, we want it less than negative 0.54, so it's be just to the left of there. So we want to shade to the left. And if I look at that z-score in table A, I actually get this. Remember, z is less than negative 0.54. You should get an area of 0.2946. Okay, on number 13, we want 40% of all observations are less than z. So I've actually given you the p-value of 0.40. All right, so now what we're going to do is we're going to go to table A, and we're going to look for the one that is closest to 0.40, okay? Now, if you look here, about right here, notice it's 0.36. 0.40 is going to be somewhere around here. So the one that is closest to 0.40 is going to be 0.3974 and 0.4013. Now, if you look at that, which one is closer to 0.40? This one is 13 away, where this one is 26 away. So we're going to go with this number here, 0.4013, and that's going to give me a z-score of, let's see, negative 0.2, and I believe it's 5. Yep, negative 0.25. So I'm going to move that out of the way. So my z-score, let's write that down. All right, so if I have a p-value of 0.4 and I have a z-score that's equal to negative 0.25, so negative 0.25 is going to be slightly right there, and we can just mark it right there, and that's what we're looking for. On this next problem, we're looking for the percentile of 0.95. So I know it's going to be on this side, so I'm going to look at my table A real quick, and if you notice, 0.95 falls in between, exactly in between these two numbers right here, 0.0505 and 0.0495. In fact, it's right smack dab in the middle. So what we're going to do, this is negative 1.64, and this one is negative 1.65. So we're going to split the difference, and we're going to use a z-score of negative 1.645, okay? All right, and we're going to take that z-score of negative 1.645, and we're going to, I apologize, that's a positive 1.645. That's going to be slightly here, and so we're going to shade to the left because we want and that would equal the 95th percentile. Now, on this last problem, SAT scores have an average of 500, standard deviation of 1. How high must this person score to be in the top 5%? Remember, if this is 5% on this side, you're going to have 95% on the left side, which is just like the previous problem. So we're going to use the same z-score as the previous problem of 1.645. And in doing so, z equals x minus mu divided by standard deviation. And we're going to solve for x because we want to know what the score is. Well, I'm going to use 1.645 as my z-score equals x minus 500 divided by the standard deviation of 100. If I follow my algebra and I multiply by both sides, I get 160, well, let's round this up to 165. Let's do that, or 1.65. So this is going to be 165 equals x minus 500. If I add 500 to both sides, a person will have to score 665 points to be in the top 5%. On problem 16, we need to identify the population and sample group. Well, the sample group's already listed for you in the initial index of the problem. So the random sample of 50 12th grade men in Texas. So our sample is 50 12th grade men in Texas. So it's this one right here. Okay, so there's 50 of them. Well, take away that 50, and we want to talk about all 12th grade men in Texas. So that's going to be our population. So our pop is going to be 12th grade men in Texas. And I guess we could say all 12th grade men in Texas. All right. Now discuss whether you think the distribution is symmetric or skewed. Well, two things you need to look at. Look at the median of 179.9 and the average. Notice they're only 0.1 away. They're relatively the same number, all right, or very close to it. Therefore, that tells me that it's going to be symmetric. if both the average and the median are basically the same number. All right, and we'll talk about inferences as we go through this problem.